Welcome and hello. This is a video lesson in the FHWA hydraulic toolbox, specifically about curb and gutter calculator. This is one of the calculators that is included in this software, and this is the lesson where we're going to talk about it. All right, so up on my screen here, I have the FHWA hydraulic toolbox, and I have a project already started with a channel analysis calculation already performed. But what we're going to be talking about is the curb and gutter calculator or curb and gutter analysis. So go up to your calculators menu and then click on new curb and gutter analysis. That will add a new curb and gutter analysis right here in your project explorer. Another way to add a curb and gutter analysis is by clicking on the button right here. This one is new curb and gutter analysis. So boom, there's number 2. And then the third way to add that same analysis is to just right click on your project and new curb and gutter analysis. So I'm going to delete those last two, delete, and then here is another delete. Oh, we can also rename this specific analysis. Just go right click and rename. You may want to name it something specific to maybe the location of where this is taking place. I'll just say Park Street on the 200 to 300 block, just making something up. And then to open up the actual calculator, you'll go right click curb and gutter data, or you can just double click on this particular analysis. Boom. All right. So we're up and ready to roll. The hydraulic toolbox curb and gutter calculator estimates water spread and flow in gutter systems and evaluates inlet performance to aid in roadway drainage and stormwater design. I'm going to bring up the PDF. This is the user's manual. So this is covered in chapter 8, starting on page 30. And here is the icon for curb and gutter calculator. And it describes basically the user interface. Here's an image, as well as a number of the things we're going to talk about in this video. All right, so just to break it down here into a left and right half, or a first and second half. Over on the left, we have a gutter calculator where we input some gutter properties, click the compute button, and then get some results. And then with those flow results, we can design the inlet by specifying some parameters over here in what I'll call is the inlet calculator. And then once we have all that set, we can click this button to compute inlet data, and we'll get some inlet calculations and performance data down here. So that's sort of a guideline on where we're going with this video. All right, so let's start on the left half here. This is the gutter calculator and the different parameters. I'll just go through them one at a time and also sort of do a working example. Longitudinal slope of the road. This is the slope of the roadway. So 0 if it's completely flat, but most likely there will be some slope. So I'll just say something small like 1%. Next, we have a cross slope of pavement. This would be the slope from the center of the roadway down towards the face of the curb, which is not uncommon to be something like 2%, so 0.02. After that, we have this checkbox here to define cross slope of gutters. You would use this checkbox and then specify a different slope in the event that it is a different slope for the gutters. So if the gutter slope was 3% and then the cross slope pavement was 2%, these would be the numbers that I use. I'm also going to bring up a PowerPoint which shows some different diagrams and images. This first diagram here shows constant cross slope, and then below that we have composite cross slope. So with that checkbox checked on, we would be using the composite cross slope, where we have the slope of the road at 2%, the slope of the gutter at 3%, which is that S sub X and S sub W with a total top width T with a contribution from the street as well as from the gutter. All right, so I'll just go ahead and use these numbers for now. Manning's roughness is 0.015. That's typical of concrete, worn concrete. And then the gutter width is 2 feet. That may be a little bit too much. We'll go with 1 feet or maybe 1.5 feet. Now let's go with 2 feet. That's fine. And then after that, we need to provide either the design flow or the width of the spread. If we use design flow, then this would be the peak stormwater runoff rate that the gutter must carry. So this is design flow, what it says, something like 2 CFS. That may be too much or too little, kind of depends on what all the hydrology states for this particular street location. Or if we click on width of spread, we'll click on this radio button here. This is the horizontal distance that the water extends from the curb face out into the roadway. So if we said maybe 4 feet right there and our gutter width is 2 feet, then that would be the entire gutter plus another 2 feet into the roadway. Whichever radio button we select here, when we click this compute unknown button, then that will calculate the other value that's grayed out and not editable. And then it will also calculate some of the gutter parameters down here. So let's just go with design flow to CFS. I'll click on compute unknown and boom, here we have our results. The width of spread for all these numbers is 8.946 feet. Gutter depression, that is actually constant based on the geometry, not the flow. That's 0.24 inches. What that gutter depression is this vertical distance here. So if we were just using a constant cross slope, that gutter depression would be 0. See, if I change this to just a 0.02, the exact same slope, and then clicked on compute unknown, see, now it's 0. Well, let's go back and change that to 3% and compute unknown. Okay, area of flow, that is just the cross-section area of flow in feet squared. E sub O, gutter flow, the total flow. This is the percentage, or I should say the ratio of flow that's in the gutter compared to the total flow. And then the curb depth right here is in inches. All right, if I wanted to specify the width of spread, maybe it's say 5 feet, I'll change that to a 5. And then when I click compute unknown, we're going to have a different design flow and different values here for area of flow, E sub O, and depth of the curb. Compute unknown. And now it's 0.47 CFS is the flow rate for this particular roadway geometry that would create a spread width exactly 5 feet wide. Then our E sub O value has increased to 0.781. So there's a higher percentage of flow in the gutter than in the street compared to when we were using 2 CFS for our flow rate. That makes sense. All right, the second half of this calculator is the inlet calculator. So now that we have the gutter designed, we want to figure out which inlet would be best for capturing or intercepting the flow based on this street geometry. Our options for inlet location are inlet on grade, like inlet on a continuous grade, or inlet in sag. So inlet in grade or a continuous grade is more common. This is just one inlet along the roadway with a constant slope with another inlet further downstream on the same road. The other option is inlet and sag, and that represents when a road has a vertical curve and it's sort of like a sag or a dip or a valley where the vertical curve upward requires that the inlet will have to capture or intercept 100% of the flow. There's no bypass, there's no way for the water to go around that inlet and be captured or intercepted at a different inlet. If you use this inlet and sag, you also need to provide a percent clogging. So something like 25%. Kind of depends on the situation. If it was 0%, that would be inlet is fully clear. If it was, say, 50%, then that means that only half of the inlet is functional, and that would further contribute to ponding. All right, for this example, I'm going to select inlet on grade though. Then we have the different inlet types. Our options are these 5: grate, curb opening, slotted drain, sweeper combo, and equal length combo. So if we bring up some images to show what that looks like, here's the first one. This is the grate inlet. This one's actually covered up with some debris affecting its efficiency. Here's another example of a grate inlet. It's a metal grate that's set into the pavement surface. Water enters from above. It's common for flatter areas. Water is not intercepted. Will just continue downstream or down a continuous slope. All right, the second one is curb opening inlet. Here's an image of that. An opening is cut into or built into a vertical curb face. Water enters from the side rather than from the top, and it's less prone to clogging, but less effective for shallow sheet flow. Here's the second image right here of the curb opening inlet. Right, the next inlet type is slotted drain. So this is the slotted drain here. Don't worry about this down here. This is a continuous narrow slot along pavement, and it's connected to a buried pipe. So the buried pipe you can see in this schematic right here. This is another slotted drain inlet type. You have the drain, and then below that you have the continuous pipe. You may see this along a gutter, or you may see it across a roadway. It acts like a long linear inlet that intercepts water over its length. Okay, the last two are combos. Here is a what is called a sweeper combo. This is the fourth option in that drop down. It combines grate inlet and curb inlet opening, and the curb opening is downstream of the grate. It looks like it's at the same location as the grate in this image as well. And then the last option is the equal length combo inlet. This is perhaps one of the more popular inlet types where you have a combination of the grate inlet and the curb inlet. Again, just like the sweeper combo inlet, except this is equal length. So the length right here of the grate equals the length of the curb opening. All right, so those are the images that I had prepared to represent and hopefully better demonstrate what these 5 different inlet types represent. I'm going to go with grate. If you go with grate, or you go with any of the options that have grate, such as sweeper combo or the equal length combo, then you then have to specify what kind of grate. This drop down here has the different types of grates. P178, P178-4. I'm not going to read them all, but there are 4 different options here. I'm sorry, 8 different options here, and they all have different geometries. And I don't have images of these. It's a little bit beyond the scope of this lecture, but it shouldn't be too hard to find out what those are. Okay, so once you've selected the grate type, then you need to provide the grate geometry. So the grate width, for instance, I'll say is 1.5 feet. The grate length, I'll say is 2.5 feet. And then everything else is grayed out because these other dimensions would be used for the different types of grates. I'm just going to go ahead and leave it at that and then click on this button to compute inlet data. So boom, here are my results for this particular inlet, for this particular design flow or width of spread in this case. Let's switch it back to design flow. I'll say about 1 CFS. I'll click compute unknown. Those values have been updated. And now I'm going to click again on this compute inlet data with the revised flow data. And now these numbers have been updated. And here are our results down below. The intercepted flow of 1 CFS intercepts 60.62 CFS, which is 62%. You can see down here in the efficiency, which means the bypass flow is 0.38 CFS. We also have an approach velocity and a splash over velocity. The splash over velocity is the flow velocity at which water starts to skip or splash over the gate inlet instead of falling through it. Our efficiency would probably be even less than 62% if we increase the flow rate. So let's do that. I'll say 2 CFS instead of 1, doubling the flow rate. Make sure to click on this compute unknown button first, and then after that, compute inlet data. So for the exact same inlet, now we're down to 51.3% of capture. That's 1.025 CFS out of the total 2 CFS. And then if we wanted to increase that efficiency or that capture, increase it from 1.025 CFS, we could do a few other things. For instance, we could increase the grate length from, say, 2.5 feet to 3.5 feet. We'll see what that does. Compute inlet data. All right, so that increased to 1.19 feet. We're almost up to 60% capture. So anyway, this is just like a lot of the other calculators in the FHWA hydraulic toolbox, where you have a number of different options here for inlet grates and flow data. And let's try curb opening. So for curb opening, now we need to specify the length of the inlet, 3.5 feet. We'll say there's a local depression of 4 inches. And then I'll click on compute inlet data. Okay, this is a little bit less effective, it looks like. We're back down to 51%. But if I use the combo, let's use that equal length combo. So this includes both a grate and a curb opening inlet, and click on compute. And now we're back up to 59% of that 2 CFS, which is 1.19 CFS intercepted by this particular inlet. All right, well, that's it for this lesson in the FHWA hydraulic toolbox covering the curb and gutter calculator.